Welcome to another video. You see, when a mathematician or a student is presented with a quadratic equation to solve, you just say, I'm just going to factor it. If factoring doesn't work, you try completing the squares or you use the quadratic formula. And you will always have an answer. It is either your answer is real or it is imaginary or are imaginary, okay? The same thing. When you're given a cubic equation like this, it is either you solve it by factoring, which makes your life a lot easier, or when you cannot factor, then you will have to resort to one of two methods. Either you use the method that involves hyperbolic functions, or you use Cardano's formula. A while ago, I showed you how I tried to derive Cardanos formula right from scratch without using any numbers, just from a generic cubic equation. At some point it got very messy, but I still have the video. Okay, you can check it out. But I noticed that I never used the formula to solve a cubic equation. So today we've got a cubic equation that cannot be solved by factoring, and I am not ready to do the hyperbolic functions method, so we're going to use Cardano's formula. If you've never done it, let's do it together. Let's get into the video. So if we go straight into the cubic equation, it is obvious that you cannot solve this by factoring, because if you move this over to that side, first you multiply every term by 3, and then you move this -1 over. You're going to end up with this. We're going to have 3x cubed. We have plus 3x squared. We're going to have plus 3x. And then this -1 comes here, it becomes plus 1 equals 0. So what we have here is a cubic formula that needs to be solved. We don't know what our results are going to be like, but at least you will get one real solution. There will always be one real solution because all cubic functions will cross the x-axis at least once. It's possible that it crosses and touches, or it crosses 3 times, okay? Or it crosses just once and that's it. And that's the case in this, that's the situation in this case, because we're only going to get one real solution, which is what the person told me. By the way, this problem is all the way from Morocco. Okay. I like how all the questions are coming from different parts of the world. So in order to use Cardano's method, we have to depress the cubic equation. And to depress the cubic equation just means that, you see how this goes from x cubed to x squared to x to a constant. We're going to get rid of this one so that we skip one of the steps. So if you depress this cubic equation, you're going to get rid of this. So a good strategy to get rid of the quadratic term is to do a substitution. And the substitution you would do, I'm going to show you what happens. So we're going to say, let this x be y minus some letter, let's call it A. Okay? Now, we're going to decide what A is, but we don't know for now. But what we're going to do we're going to come back here to change the value of A. Okay? So, now, if x equals y minus A, then you can go here and plug in y minus A everywhere you see x and see what it becomes. It's going to be a little messy from the start if you have the formula memorized, but I don't want to show you. Let's just follow the process, okay? So we're going to have 3 times, instead of writing x, we write y minus a cubed plus 3 times y minus a squared plus 3 times y minus a plus 1 is equal to 0. Now, we got to cube this, got to square this, and this one stays the same. So if we cube this, we just use Pascal's triangle, 1, 3, 3, 1. Remember? And you just alternate the signs because there's a minus sign here. So here, we're going to have 3 times, this is y cubed. This is going to be minus 3 a y squared. You see, you're going to be reducing the exponent here. So this is binomial expansion, okay? You have to do that here. And this is going to be plus 3a squared y. And this is going to be minus a cubed. So this is what you get here. Now here, when you expand this, is going to be plus 3 equals 0. Okay, so I hope I didn't make a mistake in that expansion. No, everything looks good. So let's multiply everything out and see. This 1 is just the bad guy here, because otherwise I would say we can get rid of all the 3's, but we can't because of this 1. So let's distribute the 3's. We're going to have equals 0. So there are 4 terms in this original one. You're going to have the same thing. You're going to have 4 terms. One is going to be y cubed, one is going to be y squared, the other is going to be y, and there's going to be a constant term. So let's put everything together that contains y cubed. Well, it's just this guy. Now all the terms containing y squared will be, the terms containing y squared will be this term, and that's it. So we can say this is 3y cubed, 3 minus 9a y squared. And then let's do the terms that contain y. Let's change the color. The terms that contain y will be this term, and this term. If you put them together, let's put the positive one first. So it's going to be plus, this is 3, and then the terms that are constant will be 1 minus 3a minus 3a cubed. No, 4 terms. So we're going to have plus 1 plus 3a squared minus 3a minus 3a cubed equals 0. Okay, so all of these constitute the constant. Okay. Whew. So remember I told you we're going to make a smart substitution. This a is supposed to be some constant, but in order to be able to eliminate this square, we want to get rid of this term here. Now we have to wisely choose our a. Your a must be a number that when you plug it in is going to give you 0 here, so that this guy can disappear. And what would that be? If you play around it, so we say here, let 3 minus 9a be equal to 0, so that you have 3 equals 9a, and then a will be 1 over 3. So if you choose a to be 1 over 3, we can go back here and plug in a as 1 over 3, and things are going to be a lot easier. Okay, we're going to do all the side work. Okay, so then if a is 1/3, this stays. We have 3y cubed stays. This whole term is gone because then we're going to get this to be 0. If you plug in, if you do the evaluation here, let me just do it here. Okay, so this is going to be 3 plus 9 times, since a is 1/3, we're going to have 1, let's say a equals 1 over 3. That's the smart substitution. I needed to show this, but you didn't have to show this work. You could have done this on the side to find what this expression is going to be. 3 plus this is going to be 1/3 squared. That's 1 over 9 minus 6 times 1 over 3. So what comes out of this? This is going to be 1. 3 plus 1 is 4. This is 4 minus 2. That's going to be 2. So ultimately what you have is just plus 2y. Okay, now let's go to the third part. We're going to try to plug in the numbers. This is going to be 1 plus 3 times 1 over 9 minus 3 times 1 over 3 minus 3 times 1 over 27. So those are all the numbers. here we're going to have, let's change this. There's going to be 1 plus 1/3 minus 1, minus 1/9. Okay, what does that give you? Well, these 1 and this cancel out. 1/3 minus 1/9 is 6/27, which is 2/9. That's going to be plus 2/9, and that's equal to 0. So this crazy thing that we wrote here, because we chose the correct A, we have depressed the cubic, and now what we have is 3y cubed plus 2y plus 2/9 equals 0. And this is what Cardano says we could easily solve. Okay. Now, for Cardano's formula to work, we want the leading coefficient to be 1. So in order to do that, we want to divide everything by 3 first. So let's try and do that. Now, by Cardano's formula, this is y cubed plus py plus q equals 0. So now, because we've been able to write this quadratic in this form, now we can just use Cardano's formula. What does Cardano say we gotta do? Cardano says, first find the discriminant. You see how we find the discriminant? Square root of b squared minus 4ac for a quadratic equation. For the cubic equation, this is the discriminant. It's going to be p over 2. P over 3 cubed. Yes, P over 3 cubed plus Q over 2 squared. See, they're very similar. Just know that the first is cubed, the second is squared. Okay? Just as in the original equation, right? So you want to say P over 3 cubed Q over 2 squared. That would be the discriminant. Let's determine what that is. In this case, what is P divided by 3? Do the work. So this is our P and this is our Q. Okay? So now P over 3 is going to be 2/3 divided by 3, which is going to be 2/9. If you cube 2/9, it is 2 cubed, that's 8 over 9 cubed is 729. 9 times 9 times 9. If you go here, Q is 2/27. If you divide it by 2, it's going to become 1/27, because that 2 will take out this 2. So what is 27 squared? Oh, it's the same thing. It's 729. So you notice that when you add these two together, the discriminant is going to be 9 over 80 over 729 rather. My mind is going faster, which is equal to 1/81. So the discriminant is 1/81. What does the discriminant tell us? The discriminant, whenever it is a positive number, note that, whenever the discriminant is positive, it means that your cubic function that you're dealing with is going to look like this on the graph. It's only going to cross the x-axis once, and then you're going to have 2 imaginary roots. So here there's only one real solution and 2 complex roots, not just imaginary. Let's use the word complex. Okay? That's the implication of this. Now, if what we got was a negative number, it means that you have 3 real roots. It means your graph crosses 3 times like this. Cha, cha, cha. You see that? And this is the hardest problem, because all your answers are going to be expressed as complex numbers, even though they're real. And converting from complex numbers to real numbers is the hardest thing when it comes to Cardano's formula. That's why it's not as popular as it should be, because it is very effective. And the third one is if you get, if it is 0, if this calculation we did ended up with a 0, it means you have at least two real solutions. So it's either you have a case like, let me show you. It's either you have a kiss and a cut like that. One kisses, so it is gives you a double root, or it is a cut. Or you might just have one answer 3 times. Okay, like if somebody gave you x plus 1 cubed, so you get only one answer. Okay, but here we have only one real solution and 2 imagined or complex solutions. So let's find our solution. The value you're looking for, y, which is the cube root of this equation, is going to be equal to, there are 2 parts. Let's call it u plus v. Okay, you're going to see why, because we need this also to be able to find the complex roots. Okay, so it's going to say y is equal to u plus v. Okay, now what is u? U is equal to the cube root of negative q over 2 plus the square root of the discriminant. V is equal to the cube root of negative q over 2 minus the square root of the discriminant. Do you see how easy it is? Because once you have found this, you just need to remember this, change the sign on the other one. So it's more like the plus or minus of a quadratic equation. We know that u is equal to the cube root of, let's do this mentally. This is, see, q over 2 is, this is our q. If you divide this by 2, you get 1 over 27, right? So 1 over 27 is what you have here, negative 1 over 27. We have negative 1 over 27. Let's put a negative here. Plus, what's the square root of the discriminant is 1 over 9. That's the square root of this. So it's just 1 over 9. The same thing, v equals the cube root of negative 1 over 27 minus 1 over 9. Now, if you do the basic arithmetics, this is going to be 3 over 27. 3 over 27 minus 1 over 27 is just 2 over 27. So the cube root of 2 over 27 is what you have here. Let's go here. So we say that x equals the cube root of 2 over 27. That's the cube root of 2 over, the cube root of 27 will be 3. So we're done. And here we have plus, not x, y. And here, if we do the same thing, remember we're adding the 2. So if we do the same thing here, it's going to be, this is going to be 3, 3. Negative 4 over 27. So cube root of negative 4. The cube root of negative 4 is going to be negative cube root of 4. So we can change this symbol here. So it's minus the cube root of 4 over 3. That's the real root of this equation. But remember that we were not looking for y. Our original problem told us to find x. We just said let x be y minus a, and our a was 1 over 3. So we can go here and say that x will be y minus a, x will be equal to over 3. So it looks like x equals the cube root of 2 minus the cube root of 4 minus 1 all over 3. This is the only real solution. So if you want to find the complex roots, very easy. Okay, very easy. You're going to say u plus v divided by 2. And you're going to say u minus v divided by 2. Okay? You're going to say plus or minus here. See, it's easy, right? I'm trying to build it because there's still some parts. Remember, it's supposed to be complex. So here, you're going to multiply this one on the right by imaginary cube root of 3. Imaginary, not cube root, square root of 3. So that's what makes it complex. And on this side, you just need to put a negative sign in front. That's it. I hope you learned something. Just make up a cubic equation, graph it on Desmos, try and see the formulas, try and see the numbers, the number of roots, and then use this process and compute it by yourself. You will be a happy person. Never stop learning, because those who stop learning, stop living. Bye-bye.